students. Today we would be discussing another topic of Unit 2, that is combination circuit, which is half subtractor and full subtractor. So in half subtractor and in full subtractor, we would be having the subtraction of the bits. So first of all, we would be discussing half subtractor, which is an essential combination circuit, which is used in digital electronics. This circuit is used to perform two binary digit subtraction, and this circuit gives two outputs, the difference and the borrow. So from the block diagram, it is clear that we have taken two inputs, A and B, which are being given to the half subtractor, and the output is taken as difference and borrow. So again, to start with, the truth table of half subtractor is being depicted over here, in which we have two inputs, that is A and B, with four possible combinations and two outputs, that is difference and borrow. For the two inputs, 0 minus 0, difference would be 0, and therefore the borrow will also be 0. If we do 0 minus 1, we will have to take one borrow. So as we cannot subtract 1 from 0, so since we have to take the borrow, we have borrow as 1, and 1 0 minus 1 will give us 1. Therefore, the difference will also be 1. For the third possible combination, 1 minus 0, for 1 minus 0, difference is 1 and borrow will be 0. And for 1 minus 1, that is the fourth combination, difference would be 0 and the borrow will also be 0. So for A and B, as the input variables and difference and borrow are the output variables, the SOP form of the output is as follows, that is A bar B plus A B bar, as we can see from this truth table. For this one, A bar B plus A B bar are the two combinations where the value of difference is 1 and 1. For borrow, the value is 1 only for A dash B. Therefore, the value of borrow is A dash B. This can be simplified, or this can be calculated with the help of K-map also. So for the difference, we have A bar B plus B bar A, as we can see from the K-map for sum, and for borrow, we have A bar B. And with the help of these expressions, we can draw the circuit diagram of half subtractor. So for difference, we have A XOR B, and therefore we have used a XOR gate with the inputs A and B, and for borrow we have A bar B, and therefore for borrow we have A bar, that is a NOT gate or an inverter is being used, as the input is given as A and the output of the NOT gate will be A bar, and this will be given to the AND gate, that is A bar into B, which will give us the borrow as A bar B. So this is the circuit diagram of half subtractor. Now we come to full subtractor. Full subtractor is another combination logic circuit which is used for the purpose of subtracting two single bit numbers. It takes into consideration borrow of the lower significant stage also. So it is better as compared to half subtractor, and it has the ability to perform the subtraction of 3 bits. So since it can subtract 3 bits, so we would be having 3 inputs and 2 outputs. Again, the outputs would be difference and borrow. So again, to implement the circuit of full subtractor, first of all, we would be discussing the truth table of a full subtractor. So the truth table will be comprising of the 3 inputs, that is A, B and B in. That is, we can consider it as the input borrow or the third bit of the subtractor, and D as the difference and B out as the borrow output of the full subtractor. So since we are having 3 number of bits or 3 number of inputs, so there would be total 2 to the power 3 possible combinations, and 2 to the power 3 means 8 number of input combinations. And since we are having 8 possible combinations, so it will start from 0, 0, 0 till 1, 1, 1, that is 0 to 7. So for the first possible combination, 0 minus 0 minus 0, the difference is 0 and borrow will also be 0. So for the next one, 0 minus 0 is 0 and minus 1. And since we are having 0 minus 1, we will have to take 1 as a borrow. Therefore, B out will be 1. And 1, 0 minus 1 will again be 1. Therefore, the difference will also be 1. Again, for 0 minus 1, we will have to take 1 as the borrow. This will become 1, 0. 1, 0 minus 1 will give us 1. And 1 minus 0, again, it will give us difference as 1. So in this manner, we can complete this complete truth table of the full subtractor, and then based on the basis of this truth table, we can draw the K-maps, and from the K-maps, we can find out the expressions to draw the logic diagram of full subtractor. So here are the K-map for the full subtractor. Based on the previous truth table, we can write the values as 1, 1, 1, wherever the difference is given. That is, for 0, 0, 1, we have 1. For 0, 1, 0, we have 1. That is for 1, 2. Then for 4 and 7. 1, 2, 4, and 7, we have 1. So here also we have written 1 for 1, 2, 4, and 7. And combining these four combinations, we have A bar, B bar, B in. Then for the second group, we have A bar, B, B in bar. Third one is A, B, B in. And the fourth one is A, B bar, B in bar. Or we can also write it the difference in this manner, and the borrow can be written in this manner, that is 1, 1, 1, and 1. So since we are having the three combinations of two groups, and we can have for 1, 1, that is the first combination or the first group, we have A bar B in plus A bar B plus B into B in. So on the basis of this difference and B out, that is difference and borrow out, we can draw the logic diagram or the circuit diagram of the full subtractor. So for the difference, we have A XOR B in, and for borrow out, we have A bar B plus A bar B in plus B into B in. So this is the logic diagram or the circuit diagram of full subtractor. There are various applications of full subtractor and half subtractor for performing arithmetic calculations in electronic calculators. They can be used in timers and program counters. They can be used in digital signal processing and many other various applications there can be for full subtractor and half subtractor. So these are the references which we have used for our PPT or for our video. Thank you.